Hey everybody, it's Monaco here. I want to give a shout out to my homie Milks. That one's for you, buddy. I'll be recording the rest of the videos this year solo because I've extended day and I'm unable to go to World Inquiry. So to Milks students, hello. Maybe you see my videos, maybe you see his. It is what it is. Sorry I can't be there all the time. To my students, let's take it and roll with it. We got a lot to do for the end of the year. So this unit is called the physical behavior of matter. And we're going to focus on how matter and energy are always interacting. The big idea here is we're going to learn our gas laws, okay, and a few other little intricacies related to reference tables. So let's hit up our lesson targets, our learning targets, okay? So there we go. What we're going to learn, how we're going to learn. Let's do it up. So the first thing you want to know is that how does heat change motion of particles? Heat and particles interact. We're going to investigate how they do so. Okay. The next thing, how are temperature, motion, kinetic energy, and heat all related? They're kind of going to have an effect on each other. Okay. They're not the same thing, but they're all related. We're going to investigate that further. How do you measure changes in heat for physical and chemical changes? Okay. We're actually going to do math this unit. We're going to put a number to how much heat has been flowing in or out of systems. All righty. There's another reference table. We're going to give a new definition for what boiling really is. And vapor pressure and boiling are related. So we're going to teach that reference table and help you understand how you can change the boiling point of liquids by changing the pressure that are exerted on those liquids. Okay. And the last portion of this unit is, are the behavior of gases predictable? The answer is, of course, but how is the details that we'll be studying. Learning targets. You want to be able to say that I can do the following. Distinguish between heat and temperature. They're not the same thing. You want to know the details and why. You want to be able to convert between units of temperature using a reference table on table T. It's a very easy equation. Convert Celsius to Kelvin, Kelvin to Celsius. That's one of the objectives here. Understand what STP is and why we need it as a constant of measurement for comparing the behavior of matter, okay? You want to be able to identify phase changes and changes in amounts of heat using heating and cooling curves, an object that we will learn how to draw and label. So you can do those things, measuring changes in heat and the changes in phases. You want to be able to track energy through the heating or cooling of a substance, typically water. We're going to do that with our heat equations and our heating and cooling curves. You want to understand the relationship that table H is teaching us between vapor pressure and boiling. That's that. Understand when changes in heat and chemical reactions occurred. So reference table I you've seen on your reference table quizzes, it has a delta H, change in heat. So we're going to understand what the positive and negative signs mean and how if we change one of those equations from that reference table H, the amount of heat will increase or decrease or change its sign as well. Understand this kinetic molecular theory. It's the rules for how we like to think about gases and how molecules collide inside of a container, creating pressure and all that other stuff. So kinetic molecular theory underpins the behavior of gases. And we're going to describe the behavior of an ideal gas with respect to temperature and pressure. So as you change pressure, what happens to the behavior of the particles in the gas? As you change temperature, how, etc., how they're related. And then we'll finally use the combined gas law to track changes in temperature, pressure, and volume before and after you've affected a system. So if you've got a sealed container and you heat it up and there's a gas in there, what happens to the pressure? How much does the pressure increase? How much does the volume want to change? If it's not a sealed container, if it's like a stretchy balloon, how much will the volume change? And temperature, if you change the pressure, how will the temperature and volume also change? So the combined gas law is what we're going to use to track those changes in matter and how they're related to changes in energy too. Okay, so here's our tracker. This is a new one. Okay, so pay attention to the new details on the new page numbers. All right, use the tracker. Start on homework 1. Go to homework 2. Work your way through in a linear fashion. You will stay on track much quicker. It makes a giant task, which is learning chemistry, much more simple and compartmentalized if you follow and use the tracker. Okay, and I think that's all. All right. See you next video. I'm going to find this button. I'm going to click it. And I'm going to turn off this video.